Hi, this is Jesse Wells, and I am going to be explaining a sample problem similar to your question 32 in your chapter 4 homework. Now, for this problem, you're going to be doing what you have done before, I believe with question 8. Something similar. You're going to find basically your sum of, sum of squared deviations, as well as your deviation and mean and variance. But one of the bigger changes between what you've done before and now is you're just kind of doing like an analytical approach. With portion B and C, it's just making you run through two different examples of data given, and then explain how like one dramatic score can offset basically the rest of the things that we've already covered. Some of squared deviations, your deviance, and your variance. Let's just get started by finding our original sample up here. This is what I'm going to be doing as our original untampered sample. And we're just going to drop right down here. So in the sample we have 4, so n is equal to 4. And our scores are 2, 2, 10, and 2. To find our SS, or sum of squared deviations, we need to first find the mean right here, which will be adding all these values up. So 2 plus 2 is 4, plus 10 is 14, plus 2 is 16, and then dividing it by our n being 4. So 4, 8, 12, 16 being 3. And then minusing our mean from each of our scores, and then finding the sum of that. And so that'll be, let me switch colors, 2 minus 3, 2 minus 3, 10 minus 3, 2 minus 3. So we should see -1 is equal to -1 is equal to 7, which is equal to 2 minus 3 is -1. And then we're going to square each of these values. And this will be -1 times -1 is 1. 1, 7 times 7. Oh my goodness, I should be able to do this off the top of my head, but it's been a very long day. So, oh my goodness. Also, I don't trust myself sometimes when I'm doing videos. 49, and then 1. And so 49, 50, 51, 52. So this will be our sum of squared deviations. Is 49, 50, 51, is 52. Now that we have our SS, we're going to find variance next, which will just be variance is equal to SS over N, which will be equal to 52 over 4. Which should be equal to 13. And then we're gonna find our last thing being our standard deviation, which will be just the square root of our variance. So we'll just square 13. Square root of 13. 13 squared being 3.0 3.61. So yeah, just to help us with portion B, I'm going to write all this on a new page, move this up here, and write down what we found for our A sample. A sample, we found SS to be equal to 52. Our variance to be equal to 13. And then our standard deviation to be equal to 3.1. Okay, so now with our portion B, the text is basically telling us to switch our extreme number, which in this case, with our scores, we had 2, 2, 10, 2. It's basically saying to switch out this 10 for instead a number that's within like a similar variance to it instead. So let's switch it to a 3, just so that they're all not all 2s and it equals 0. So yeah, we're going to do the same steps that we did before. And then for part C, we're going to compare the two. So first, let's start by finding our mean. And to find our mean, we just add our scores up together again. So 2 plus 2 is 4. Plus 3 is 7. Plus 2 is 9. And then we divide our sum of scores by the number of scores we have, being 4. So 9 divided by 4 should be just is 2.25 being our mean. Now that we have our mean, we're going to find our sum of squares. Sum of squared deviations. So that will be each of our scores. Let's do 2 minus 2.25 to 2.25 to, 3 minus 2.25, and then 2 minus 2.25. So 2 minus 2.25 will equal negative 0.25, which means all these other 2's will also equal 0.25, except for that one. 3 minus 2.5, 3 minus 2.25 is equal to 0.75. It's actually positive. And then we square each of these scores. So 0.25 times 0.25, so negative 2.5 times negative 0.25 would be 0.0625. It'd be positive because a negative times a negative, so let me use a different color. 0.0625. 0.0. That means this will be 625. So I'm just going to times this by 3 for the sum. Let's write that down over here. 0.1875. And then 0.75 times 0.75. 0.75 times. Will be 0.5625. So 0.5625. Adding all these up together, 75 will equal 0.75. And this will be our S or sum of squared deviations. Now to find our variance, we take that same score like we did before, and we just do 0.75 being our SS and divided by our total number of scores being 4. So 0.75 divided by 4 is equal to 0.1875. It's equal to this. And then we just square it. That'll be our final standard deviation being square root of 0.875 equaling this, which will be 0.4330. And so just to write it up here so they're next to each other, we have our SS over here being 0.75, our variance being 0.1875, and then our standard deviation being 0.4330. And so you can pretty much see already, this will be now answering question part C, being how does an extreme value influence mean and standard deviation, or well, all these things. And it's really like how you see the scores from before, right? We have 2, 2, 10, you know, it's a really big number, and then 2 versus 2, 2, 3, 2. There's just so much difference between a 2 and a 3, like 8 spaces over, that it will completely skew data. It'll like push it towards the end of where the 10 would be. So like, for example, mean, right? If we do mean, mean for our part B, where it was 2, 2, 3, 2, was just a variance, a mean of 2.25, versus for our first portion of the problem, it was, remember correctly, where did I write it down? Sorry. It was 16. So, actually, no, that's not correct. 2, 2, 10. 10 plus 2 is 12, 14, 15, 16, 65, 4. It was 3, sorry. So, it moved our mean up by nearly a full unit. Going on to how it affected our sum of square deviations, our current score of SS was 0.75 versus our one before was 52. A very big, not a decimal, 52. It's a very big jump between what our deviation should be. It's very much skewed towards our 10 value. For our variance, since our numbers are so varied, for the first sample where the 10 was included, it's a 13, versus for our new set where we changed the 10 for a 3, it's below 1, meaning that there isn't much difference between all of the current answers. So lastly, being our population standard deviation, our first portion of the problem was 3.16 versus our current one being 0.4330. It's a similar situation to the sum of square deviations, where because of that 10 value, it's really pushed it towards the 10 value. Like if you had a graph, for example, if we had like 2, 2, 2, 3, 2, we'd have a little hill, versus if we have 2, let me use a similar color, opposing color, 2, 2, 10, 2, very much like it pushes everything up. So where our mean would be completely different. So yeah, if you need any help with any more problems like this, then please let me know. I hope that helped you, and thank you very much.